All right, we'll go ahead and get started. Hello, everyone. On behalf of the Environmental Finance Center Network, welcome to another webinar in our PFAS Today, Tomorrow, and Forever series. Today's session is on how do I know if I have a PFAS problem? My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for the session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or if you need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or if your utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. Before we get started, I would like to quickly highlight some of the relevant upcoming events at EFCN. The next webinar in this PFAS series is on effective treatment for forever chemicals. It's coming up on Tuesday, April 9th from 1 to 2:30 p.m. Eastern, and I will share the registration link in the chat with you all. We also have an upcoming PFAS peer-to-peer session. This is a facilitated regional conversation to prepare and strategize for the coming PFAS regulations. Come prepared to ask questions to other professionals and share your experiences and thoughts on PFAS. This last session will be facilitated by the Southwest Environmental Finance Center. And I will also be sharing the registration link to this as well in the chat. And on that note, we can go ahead and get started. I would like to introduce our presenter for today, Will Shaffer. Will is a project engineer at EEC Environmental, and he is leading this PFAS webinar series. Welcome back, Will. And before I hand it over to you, we're going to go over just a couple of poll questions to kind of gauge and see where our audience is coming from and what type of PFAS knowledge that you have. That's the first poll question we'll be asking you. Launching that right now. So what is your level of PFAS knowledge? And I'll give everyone about 10 more seconds. Go ahead and just get your answers in. All right, well, it looks like 75% say I am learning about PFAS, but no actions yet. And then the second most popular, 19%, they are brand new to PFAS. And next poll question, what is your current role? And it looks like most people already have their answers in, so I'll give everyone just a couple more seconds. Thank you for participating in these polls. All right, 3, 2, 1. All right, almost half are regulators. We've got plenty of wastewater system operators, some engineers and consultants in the crowd today, and then 21% are others. We'll gather that information at the end as well with our post-webinar survey. And I'm going to go ahead and pass things over to you, Will.
Excellent. All right, let's get this started. Thank you so much for having me again, and welcome to our latest series, or our latest episode in our series that we're calling PFAS Today, Tomorrow, and Forever. A little bit tongue-in-cheek with the title there, but today we're going to talk about how do I know if I have PFAS in my water, wastewater system, in my community, in the environment around me. How do I know if I have a problem? What can I do sampling or characterization wise to determine if I have a problem? And then we're going to touch a little bit on what to do or what next steps to take if you identify that you do have a problem. So thanks for joining us in this adventure here today, and we're going to get started. Thank you so much for responding to the questions there. That's really helpful for me. I'm going to try to kind of tailor what I talk about here to the audience that we have today to try to make this more useful for you, or as useful as it can be. So to that point, we're going to start with an introduction of myself and EEC for those of you who are new to this series, who haven't heard about PFAS before, or who are still, there's about 20% of you that are brand new to it. And then almost the rest of the audience here today is still learning about PFAS and what the impacts are of it. So we'll touch on that a little bit. We're going to go briefly into some regulations and why those are important, how those are driving what our main topic today is, which is sampling. We're going to talk about sampling methodologies, what lab analyses there are available to us, both for water and wastewater systems and otherwise. And then we're going to talk about what are the efforts to undertake to put together, say, a sampling program, characterization of a wastewater collection system or similar. So when we know what sampling methods we have, how do we apply those to our specific situation? And please feel free throughout the webinar to type any questions into the chat, and we'll, if there are important questions that are kind of germane to what we're talking about, we'll try to address those in real time. Otherwise, we do get that feedback at the end of it, and we do try to reach out with answers to any unanswered questions. There's been a lot of questions submitted by the audience. Thank you so much for that. And to that point, we kind of extended our time frame here today. Our last two webinars, we had kind of gone over our allocated time to address a lot of really good questions. And so we've extended that Q&A time frame here today to allow a little more access to answering those questions in real time. So please feel free to submit those questions. If we don't address them in real time, we're going to get to them at the end of the webinar. We're not chock full, jam-packed. We're not an hour worth of content here today. So there should be plenty of opportunities to get to those questions. So moving right along, a quick introduction to myself and to EEC Environmental. My name is Will Shaffer. I'm a civil and environmental engineer, professional engineer, licensed in just about half the states across the US. That number is increasing every year. But I work with EEC Environmental. I work for EEC Environmental. I'm a project manager, project engineer here, working on kind of a wide range of environmental and civil projects. And EEC Environmental, we're a national environmental engineering consultant. We're headquartered here in California, but we have an office on the East Coast as well, and some people located strategically throughout the US. And we provide kind of a national reach for our clients, which are municipalities, cities, wastewater and water agencies, private industries, commercial developers, industrial developers, kind of runs the gamut here. So it's been really beneficial as we've been exploring this brand new world of PFAS because we get to be exposed through our clients who are asking these questions to how PFAS is impacting all sorts of different folks across the spectrum of private and public industries and municipalities all across the US, projects in almost every state here. So we've gotten a great opportunity to get exposure to PFAS impacts in many different matrices throughout the environment and throughout the US. And so here at EEC Environmental, what that looks like, we have a team of PFAS experts. We have chemists, we have industrial engineers, we have chemical engineers, civil engineers, geologists, hydrogeologists, all kind of at the ready to address PFAS impacts across the environmental spectrum, whether that be site investigations or remediation efforts, characterization and sampling and planning for those efforts, which is what we're talking about here today. Treatment system design. Largely that's focused on drinking water treatment systems right now. And if you attended our previous webinar last month, we talked about the impending drinking water MCLs, maximum contaminant levels. That's something that I've been involved with heavily, is designing and implementing and constructing treatment systems for that. And for those of you, I get questions a lot from you guys, and thank you so much. There will be an upcoming webinar about treatment, and we're going to talk about that very shortly here. And then a major part of what I do and what EEC does is kind of an owner's representative role, being PFAS experts. This is new to a lot of agencies, a lot of regulators, a lot of treatment systems, and those folks there may not know how PFAS impacts pretty much everything that they do and in what ways. And so we lend our expertise in those areas to help better inform the decision makers and the stakeholders in those processes and those projects. So that's a bit about us, a bit about this series, PFAS Today, Tomorrow, and Forever. This is a series. Right now we've got it at 5 webinars. We've done 2 of these so far, and thank you so much for being a participant in our 3rd series today. It started kind of with an introduction at the end of last year, as far as a very broad introduction of what is PFAS, what are the regulations, and we have been taking kind of deeper dives into certain aspects of that across these recent and upcoming webinars. Last month, like I said, we looked at MCLs and the impending drinking water MCLs, what those are going to be, what we expect the requirements to be for those, and how to comply with those requirements. Today, we're talking about sampling to help identify if we have a problem or what regulations are going to apply to us, depending on if we have PFAS in our environment or in our system. Like I said, next month we're looking at April 9th will be the date for that webinar, and we're going to put a link to register for that webinar, and that's going to be focused on treatment, and that's a hot topic. So please feel free to sign up for that webinar, and we're going to talk anything and everything about PFAS treatment technologies. And then May 7th is our 5th episode in this series, and I want to hear from you guys what you all are interested in learning about PFAS. And so we've got a poll here about what those potential topics might be. Let's see if we can open this up. Let me know, Kristen, if we're live on the poll or if I got to stop sharing here.
No, you're good. The poll is in progress.
All right. So what do you want to hear about on the May 7th webinar? Do you want to hear about destruction technologies, ultimate destruction of PFAS? And oftentimes that's accompanied with the treatment of PFAS, which is the separation, and then we got to ultimately destroy it. What about the human health effects of PFAS and how those are driving regulations? Maybe you want to hear about product substitutions. You're going to hear very shortly about the ubiquity of PFAS in consumer products and how are we moving away from utilizing PFAS chemistry. Maybe you want to hear about what might be the potential impacts from CERCLA and RCRA designations of certain PFAS constituents. A lot of that's guesswork and what best educated guesses are, but maybe that's of interest to you because that's one of the big regulations on the horizon. Or is there something else you want to hear about? And please, if you choose and select other, please feel free to type into the chat what you're interested to hear about in regards to PFAS.
All right, so almost 80% of people have voted, have put in their preference for what they'd like to hear about on May 7th. I'll go ahead and give everyone about 10 more seconds. Put in your vote. It is neck and neck right now between destruction technologies and health effects of PFAS. So
they were up at the top for a reason.
Yeah. All right, I'm closing the poll in 3, 2, 1. All right, so we've got 57% said health effects of PFAS, 54% said destruction technologies, 33% said potential impacts from CERCLA and RCRA designations, and 29% said product substitution. So we do have a good amount of support for all of them. But yes, like you said, the top two were at the top for a reason.
All right, so we'll take that into account as we start planning that May webinar, and we'll see what we can do to address the most important topics to all of you. And this is, and again, thank you for your input. We try to kind of make this about you guys and what do you need to hear about, what do you want to hear about. And so as we look, I'm a Pearl Jam fan, but we've got the rear view mirror there looking at the previous webinars and what's upcoming. So thank you for your input, and we'll have announcements, and please monitor those announcements for what that May 7th webinar is. With that, let's talk a little bit about PFAS, why you're here, and the topic of the day, of the year, of the month. PFAS 101, I know 20% of you guys are new to PFAS, so I don't want to breeze right through this, but I do want to address it. I do want to address one new concept here, that this is a familiar slide for those that may have attended the previous two webinars. But I want to address one new topic in particular that's going to come into play later in the webinar, and that's the topic of precursors. But before we get there, just kind of 101 on what is PFAS, per and polyfluoroalkyl substances. PFAS being the abbreviation of that. It is a class of chemicals. So there's maybe 5,000, maybe 10,000, 15,000, depending on how you define that class of chemicals. But these are very persistent, very useful chemicals that take advantage of fluorinated chemistry to provide heat resistance, water resistance, oil resistance for a broad range of consumer products. It started with the Teflon line for cookware back in the 40s, 50s, even that far back. And so it's been the kind of stick resistance and non-stick coating for cookware for a long time, for decades, and then it's kind of evolved through different iterations and different generations of PFAS compounds, and then utilized across a broad range of consumer products. You see some of the stuff there: cosmetics, food packaging, textiles, and water resistance for those, paints. It's everywhere, right? And so that's one of the big challenges here that we have with PFAS, is just the ubiquity of PFAS in our environment, found in soil, air, water, groundwater, stormwater, recycled water. Pretty much anywhere you look for it, you end up finding it almost. And so that's one of our big challenges. Now, the science and understanding of PFAS is still evolving. I want to emphasize that we don't know everything about this. We're trying to regulate it. We're trying to wrap our hands around it. But we still are learning as we go along. through the process here. And one of those things that we've been finding out, that we've been learning through this process, through all the sampling studies, through all of the regulatory processes, is there's something called precursors. And this is not something that was very well understood maybe even 3-4 years ago. Again, that's continuing to evolve. But we've got this kind of Venn diagram here that I think does a good job of helping us understand this, where we may have a single PFAS constituent. I've got PFOA here, PFOA, that's utilized for one application. And that is just a single PFAS constituent of the more than 5,000 that are known to exist. And then through our analytical methods, we can quantify how much PFOA we have in the environment. Or we can quantify PFOS or PFH excess, or these target compounds is the terminology used. And you see the orange circle there. With our analytical methods, we can quantify numerically our concentration of anywhere from 27 to 40 on standard analytical methods. Modified methods, we're starting to get up to like 120 named compounds that we can analyze for. But even that is a small fraction of the total PFAS compounds that exist out there in the environment. So what we're starting to do is develop analytical methods that can help us identify that. And we've got in the green circle here, total oxidizable precursors, the top assay analysis. We're going to dive a little bit more into this, but basically what that identifies or helps us identify are precursor compounds. So we've got these target compounds here in orange that we can name, that we can quantify. And then we have precursors, which are other PFAS compounds. They may be the same or longer chain of carbon that transform in various ways into these target compounds. And so we may not see those precursor compounds, quote unquote, see them in the target analyses. They may be hidden to us, but we have this top assay analysis that allows us to at least identify and quantify how many there are in this discrete sample that we have. And then even that is just a portion of all or total PFAS. And as we develop additional analytical methods, we are trying to identify or figure out ways to identify total PFAS. One marker that we've found useful is adsorbable organic fluorine, AOF method, which identifies all organic fluorinated compounds. All PFAS fall under that, or most PFAS fall under that, but then there are other compounds as well that fall outside of that that are not PFAS. So it's not exactly a total PFAS method. It's a good indicator of how much PFAS is in your sample, but there are some nuances to that. So I want to address that here up front, this terminology of precursors, these other PFAS compounds that transform either in the environment or through other mechanical or man-made or forced operations into these target PFAS compounds. And we'll talk a little bit more about that coming up. So, brief introduction to the terminology there of PFAS and of precursors, and that's going to come in handy as we move through this. Again, I always like to bring up what are the regulations and where are they going. We're not going to take as deep of a dive into the regulations themselves today. We're going to focus on sampling and characterization. But I like to keep this just kind of as contextual and background on where we're headed. It's largely driven by the EPA's PFAS strategic roadmap, which I encourage you to read and learn on your own. But this is a whole of government approach to address PFAS in the whole of the environment. So the US government is using various agencies and departments to regulate PFAS in different areas of the environment, EPA leading that effort, but it's anywhere from drinking water MCLs, which we talked about last month, to air regulations, surface water, wastewater, you name it, biosolids application. We're trying to address PFAS in the entirety of the environment and what its impacts are and how to regulate that and what that looks like. And a lot of that is addressed here in the PFAS strategic roadmap that I would encourage you to read for yourself. I've put a couple of those items that the EPA has identified in their roadmap here on this kind of timeline here. And this is a familiar slide to those of you who may have attended previous webinars, but I do want to again point your attention to these two in the middle that are highlighted in yellow here in quote unquote early 2024. We're already into March. It's kind of hard to believe, but we're well into early 2024. And so we can expect to see these quote unquote any day now. One of those is the drinking water MCLs, and that's why we did the webinar last month, was to try to get ahead of this regulation, prepare folks for how to comply with drinking water MCLs. And then the other big shoe to drop in terms of a regulation, a federal regulation that's going to have wide-reaching impacts, is that CERCLA hazardous substances designation for PFOA, PFOS. It's not exactly what we're talking about here today, but we're going to give a little bit of love today to the wastewater side of things. I know we talked a lot about drinking water last month. We're going to talk a little bit more about wastewater. And I'll point your attention to that summer 2024 effluent limitation guidelines, those ELGs and other MPDS regulations and efforts, and how those are going to affect wastewater systems, collection systems, and wastewater treatment plants, publicly owned treatment works, POTWs. So some of those wastewater folks that are out there, stay with me. We're gonna give you a little bit of attention, a little bit of education and resources today that maybe you haven't gotten in the previous webinars. With that, let's take a little bit of a deeper dive into what analytical methods we have available to us. Today, we're going to focus on sampling and characterization. We can't do that without understanding the analytical methods that help us quantify how much PFAS is in a particular sample of wastewater or surface water or drinking water. Yes, we're going to focus on wastewater today a bit, but that doesn't mean we ignore drinking water, especially with the MCLs coming up. So we'll start there. Main drinking water analytical methods, method 533 and 537.1. For those of you who attended last month or who are curious about how these apply to drinking water MCLs, both of these are being proposed as allowable for analytical methods to demonstrate compliance and meet the sampling requirements under the drinking water MCLs for those 6 constituents there. So both of these, they're very similar analytical methods. There's some minor differences. I wouldn't pretend to be a lab expert. I don't wear a lab coat like this person in this picture here. So I would encourage you to reach out to your local lab that is certified in these methodologies to help understand what is the best method for you as you look towards drinking water MCL compliance. But both of them are proposed. We'll get better clarity when EPA finalizes the MCLs, but both of them are proposed as acceptable uses for MCL compliance testing. Those are the 2 main drinking water analyses. We've got a couple here, wastewater focused analyses, wastewater and otherwise. The main one is method 1633. This was recently finalized, this method. It's not been promulgated yet under the Clean Water Act, but it is widely used. It's widely used by agencies. It's widely used by states and other regulatory agencies. And this is basically the non-drinking water analytical method. So these are various matrices, including wastewater, surface water, groundwater, landfill leachate, solid matrices like soil, sediment, biosolids, and then fish tissue. So it's a lot. It's kind of a catch-all here, but this is basically, you can think of it as the non-drinking water analysis. And for you wastewater folks, you're going to get to know and love method 1633. There's 14 analytes on that analytical list. So you're going to get 14 target compounds we talked about. I believe it was the orange circle, those target compounds. So there's 40 there in method 1633. That bigger circle as we move outside in that Venn diagram is the precursors we talked about. So this is the second method that works kind of hand in hand with 1633. This is called the total oxidizable precursors assay, TOP assay for short. And so this is a method that can help identify how many precursor compounds you have in your sample through method 1633. And this is kind of the way that the TOP assay works. I'll explain in a little bit. You do that targeted analysis first. So you're going to do that 1633 or 40 analyte list targeted analysis and quantify those target compounds. That can be a 40 analyte list. You can modify it to be more. You're going to run that sample for those 40 and quantify those 40 compounds, whether those are non-detect, 2 parts per trillion, 6, 6.5, whatever the case may be. For TOP assay, you're going to run that analysis first for that target analyte list. Then the lab is going to oxidize that sample. I won't get into the methodology of that, but they're going to oxidize that sample and then they're going to run it again. And what you're going to find after you oxidize that sample is that when you run that target analysis again after oxidizing it, you're going to have higher, generally speaking, you're going to have higher concentrations that second time around. And what we're finding, and kind of where this came from, was influent and effluent sampling at wastewater treatment plants. We started seeing effluent concentrations of these target compounds being higher than the influent concentrations. I'm wondering what's going on here. What we found is that through that treatment process, some of those precursor compounds are being oxidized and transformed into the target compounds. And so that's what this analysis is trying to mimic, is the transformation of those precursor compounds into the target. It doesn't tell you which precursor compounds they are by name. It tells you how much your target compounds have increased. So it'll tell you how many precursors for that specific target compound there may be in that sample. So it's a bit of an indirect, it says here, measurement of those precursors. It doesn't quantify the precursors individually, but it does give you an idea of how many hidden, quote unquote, PFAS you have in your sample, those precursor compounds. And then I talked about method 1621, the AOF method, which you can think of as, I hesitate to call it a total PFAS method because it's not. It's an indicator of the total amount of PFAS you have in your sample. I put it here because where it's widely being used is to try to take a mass balance approach of PFAS in some process. So we talked about influent and effluent at a treatment plant, and you have the biosolids coming out there. If you were to run an AOF analysis on influent and effluent and biosolids and get a mass balance of how much fluorinated compounds there are, you may see closer to a mass in equals mass out, not a destruction of fluorinated compounds, but you see that mass balance. And that's also being used for destruction technologies that are in pilot and demonstration phases. How do we know we are ultimately destroying PFAS? We're measuring the total fluorinated chemistry in that sample. So that's kind of where this AOF method is being utilized right now. It's kind of more in the academic world, the pilot world, the demonstration world, but it is out there and I want to make you aware of it. And I want you to understand, you may hear it as total PFAS. It's not exactly total PFAS. It's an indicator of how much total PFAS may be in your sample. I'm a visual person. I know I'm talking a lot at you, but maybe this is a good way to take home the difference here between these different analyses. This is kind of a tip of the iceberg type of approach. Is you may run this theoretical, hypothetical wastewater treatment plant influent sample or collection system sample, whatever the case may be. Say we take this discrete sample and we run it for method 1633 and we get a quantification of those 40 analytes, 40 PFAS analytes, add them all up. You don't necessarily have to do this cumulatively, but say you add them all up and it ends up somewhere around combined 100 parts per trillion of PFAS compounds in that sample under method 1633. Well, is that all the PFAS that we have in that sample? Probably not. And that's what these additional analytical methods are trying to demonstrate. We may just be seeing the tip of the iceberg. If you were to run that 1633 and then run the top assay analysis and you add up all those compounds after oxidizing that sample, you may end up somewhere on the order of 1,000 parts per trillion. So we may have had 900 parts per trillion of PFAS precursor compounds in that sample that we didn't see from 1633. And then you run the same theoretical sample for the AOF analysis, 1621, and add all that up, you may end up on the order of 10,000 parts per trillion because we're capturing all fluorinated compounds at that point. So you're starting to get the idea here that it's an imperfect science. These are the best available analytical methods, but even that, we're still learning as we go here that there's additional PFAS compounds we don't know about. We don't know where they're used, how they're used, what the health impacts of them are, but we're trying to learn and we're trying to identify and quantify them in the environment through this kind of suite of analytical methods. I'm going to breathe here because that's a lot and I get it. And we're going to try to kind of transition now from those analytical methods into now we're talking about water systems, wastewater systems, and the title of this webinar today is called, How Do I Know If I Have a PFAS Problem? Well, the only way you're going to know is if you start sampling, characterizing, quantifying. So we have these analytical methods available to us as tools to help us do that. But then where do we start? Where do we start taking samples and how do we take those samples? And there are resources available out there, and I'm going to touch on some of those. But before you start taking samples, it's important to know how you're going to take those samples and what the best practices are when you take those samples. And so there are plenty of sampling guidance specific to collecting PFAS samples that are available out there to us. A lot of states have issued their own state-specific sampling guidance. Michigan and Minnesota and New York, all these states have very specific criteria on the do's and the don'ts of sample collection. What materials can I use? What clothes can I wear? Can I wear deodorant while I sample for PFAS? What personal protective equipment do I have to wear and utilize? How do I handle that sample? How do I label that sample? All of that is addressed in these sampling guidance documents. And the intent of writing this out and being so strict on these guidance is to avoid cross-contamination of these samples. And we didn't address it as much today, but in the previous webinars, we talked about the fact that we are sampling and we are quantifying down to parts per trillion concentrations, not parts per million or parts per billion, but parts per trillion concentrations. And so at these extremely low level concentrations, it becomes very important to avoid cross-contamination in our samples. And so that's what these guidance documents are attempting to help us do, is to avoid that cross-contamination. Like I said, many states have issued guidance. I put a link here, and you can download the slides from the handouts tab in your GoToWebinar window there. And you can go ahead and click on these links in those slides. But that link down there is an EPA link that is kind of a catch-all link. It links you to some of these guidance documents that these states have issued, but I would also encourage you to reach out to your state regulators, to your environmental departments, to ask if they have issued state-specific sampling guidance. And then even those guidance, you may have a general guidance document. You may have a separate guidance document for how to collect and what are the best management practices for sample collection for wastewater, and for soil, and for surface water, and fish tissue, and so on. So it gets very specific, and these are great resources for those that are looking to start sampling for PFAS that maybe haven't done it before. I would always encourage you, before you implement on any level of sample collection, in particular a sampling program, which we're going to talk about here shortly, to have a very detailed work plan that addresses where you're going to sample, how you're going to sample, what are these requirements, sampling requirements, what analytical methods are you going to run, what labs are you going to utilize, what are your detection limits going to be, so on and so forth. A very detailed work plan out front, and rely on the experts around you to help you craft that work plan. And it may look very different for PFAS than it has for maybe something else that you've done sampling studies for previously. So rely on the expert consultants around you that have expertise around PFAS. And please, please rely on your labs as well. Utilize your labs as a resource. They have a lot of great people there at the labs that can help answer a lot of these questions and help you understand the difference in the analytical methods, when to use one versus the other, what sampling equipment and bottles you're going to need, and so on and so forth. So don't go it alone. Pull in the experts to help you develop those programs as you start down this road of sampling and characterization. So again, this is a lot. We're going to pause to take a breath here before we get into some of these characterization efforts and kind of a case study and not look at it. But what have we talked about so far? A little bit of a recap. One, there are regulations that are driving a lot of this. We didn't take a deep dive into those today, but know that those regulations are ever changing. There are new important regulations soon to be adopted and finalized that are going to have far-reaching impacts. And then even as we go through these processes and the public notifications and comment periods, those regulations themselves, from the proposed stage to the finalization stage to the adoption stage, are evolving. Sampling, we have various analytical methods to utilize for very specific purposes and very specific matrices. So understand the difference between 533, 537.1, 1633, 1621, and where and why and how to apply those analytical methods to the sampling program that you are developing. And understand that even within that, and again, just as the regulations are evolving, our analytical methods are evolving. And so we may only be seeing some of the quote unquote PFAS picture in any specific target analyte list or method. And then just keep that in mind in the context of these ever changing regulations, that the quote unquote game may shift next year or 5 years down the road or 10 years down the road. And I'm going to talk about why that matters when we're talking about capital improvement projects and the like. And then expertise. Experience counts when it comes to PFAS. Please rely on the experts. expert consultants in your state or in your region that have this expertise that can help define those parameters and build that program, and then your local labs that are certified in these methods to help you understand how to run these methods, what methods to run, and what equipment and sampling materials are necessary to collect those samples. So with that, having talked a bit about the analytical methods themselves and the sampling procedures and do's and don'ts and guidances, I want to talk a little bit about if you find yourself as a wastewater or wastewater system embarking on this world of PFAS characterization and program and sampling program development. I'm going to touch on this. I'm going to breeze through it a little bit, and hopefully there's some Q&A generated from it that we can take a little bit of a deeper dive into some of these aspects. But where it all comes from, I like to keep context in mind, is the entire PFAS environmental cycle and the ubiquity of PFAS. And you see it here, each one of these processes are known to have PFAS impacts in them: drinking water, wastewater, river discharges, surface water, all of this. And so this is the challenge of quantifying how much PFAS is in any one of these arrows or text boxes and how it impacts the overall cycle. And then how do we address those impacts? And some of those might be more clear-cut than others. But this is the end goal of a sampling or characterization program, is to quantify the PFAS impacts in any one of those stages in the environmental cycle here. And so with that in mind, we asked the question, why would we sample? Why would we sample for PFAS? It seems like everywhere we look for it, we find it, which is kind of true, kind of not. Sometimes we don't find it where we expect it. Sometimes we find it when we're not looking for it, really. It's just kind of the nature of the beast here. But what would drive someone to develop a sampling or characterization program and to start investing, and it costs a lot to run these analyses, investing the cost to implement these programs? I've kind of put forth, there may be more reasons why to start sampling. I'm going to touch on these 4 briefly. I'll start in the bottom left here, environmental stewardship. Maybe it's just the right thing to do, to start addressing forever chemicals that are ubiquitous in our environment and get a head start on that. I've got a picture of a hangar here at Houston Airport, and you see what looks like snow in Houston. Really what it is, it's fire suppression foam. And this happened just last month, I think it was. I saw it in the news. And this looks like a terrible PFAS problem, because we know that PFAS is present in AFFF, the firefighting foam that you find in these fire suppression systems in airport hangars. And it looks like a terrible PFAS problem that's going to be a big issue for someone. Turns out it wasn't. Turns out this is United in this case, had recently changed out the suppression system to non-fluorinated foam. F3 it's called instead of AFFF. And so this is PFAS-free foam. It was an accidental discharge, but at the very least, they had already taken the proactive step of changing out their PFAS-laden foam, AFFF foam in their suppression system, to non-fluorinated foam. And so potentially a major release to the environment averted here by good environmental stewardship. One might be regulatory compliance. I'm going to dive a little bit further into this, but you'll see the graphic here on the right, bottom right. This is a DoD graphic. They have, the Department of Defense has installations across the US. You see them dotted here, Air Force and Navy and others. And the historical use of this AFFF fire suppression foam at these military bases, and a lot of it was training, fire suppression training for response to aircraft fires. And the use of that AFFF foam in the training being a release to the environment. And so they have identified 715 installations across the US where they've done investigations, and something like 120 of those required no further investigation. And then they're continuing down the process of additional investigations and site remediation if appropriate at the remainder of the installations. So you may have a regulatory requirement driving that, and that's the Department of Defense driving that, and Congress driving the investigation efforts at these DoD installations. I'm going to talk a little bit about MCLs and MPES as well. The other thing you might want to just mitigate your future risk. We've got CERCLA and RCRA designations on the horizon, proposed rules for hazardous substance designations and hazardous constituents designations. And if you know anything about CERCLA, these would be Superfund sites. Most people know it as the Superfund program. This is cradle to grave responsibility for hazardous substances. So anywhere from the minute you receive it, you handle it, you dispose of it, cradle to grave, the life cycle of this compound, this hazardous substance, in this case, PFOA or PFOS. So you may want to address it now just to mitigate future CERCLA risks. That may be a driver for trying to identify where you have PFAS impacts, maybe on your site or on a previous site or in your supply chain or something like that. And then lastly is project protection, which is kind of an ambiguous term, but a lot of water and wastewater system operators and owners on here and regulatory agencies approving these projects. These would be large capital improvement projects. This may be a large POTW upgrade project. This may be additional treatment, an advanced water treatment facility, an AWTF that you're looking at designing, or the feasibility of, or a demonstration facility ahead of full-scale implementation of AWTF, or groundwater supplement, or maybe indirect or direct potable reuse here in the arid West states, looking heavily towards that. We may want to embark on PFAS sampling characterization to understand how PFAS are going to impact these very major capital improvement projects that represent some of the largest dollar spends in our budgets. It's best, you may have like a 10 or 20 year CIP program, best to understand now how PFAS may impact the scope and cost of those projects as you move forward in your CIP. This is an example of project protection here. I know the graphic may not be the easiest to read, but it's an idea of the water cycle and a one water approach of closing your water loop in a water system. In this case, this is from City of LA. And the takeaway here is these red boxes are areas of a one water approach utilizing stormwater, surface water, wastewater, recycled water, and potable water, and the intersection of all of these. These are areas where PFAS definitely impacts that one water cycle, but we may not have a great idea of how it impacts it. We may not regulate it yet. We may not have done extensive testing or sampling to understand the impacts of PFAS in any one or all of these areas. And so this just kind of demonstrates and highlights the unknown aspect of PFAS in these major projects and why it's important to understand those up front, because there's a lot of boxes there. And then again, regulatory compliance, we'll touch on what a few of those regulations may be. We talked about drinking water in the last webinar. I'd encourage you to go watch it if you're curious. And two of the major drivers of sampling for PFAS in drinking water, one is the UCMR 5 program, where the EPA is doing PFAS sampling in public water systems across the nation and publishing that data. And there's links to that information in that previous webinar. And then the drinking water MCLs on the horizon here are going to drive a lot of that sampling as well. There's sampling and monitoring requirements in the upcoming MCLs for drinking water. So that's going to drive a lot of sampling efforts for a lot of us. We talked about future CERCLA and RCRA designations being upcoming or impending regulations. These are kind of big regulations with far-reaching impacts, and you may be talking about sampling soil and groundwater and surface water, all in relation to one Superfund site that may be listed or that may be modified in its investigative orders to start addressing PFAS impacts where it previously wasn't, if it's a historical Superfund site. Biosolids, this is a big one. Our friends up in the Northeast in the state of Maine is the first state to restrict biosolids applications from wastewater treatment plants to agricultural beneficial reuse because of the impacts of PFAS in those biosolids. PFAS is found in the biosolids, and then we're spreading those biosolids across agricultural lands. There's a concern for uptake in the crops there, as well as the concentration of PFAS found in near surface and superficial soils at these sites. And so you can Google Maine biosolids PFAS, and you can see the impacts that that's having in the state of Maine as kind of a case study for how biosolids land application may be restricted or regulated or addressed in the future. There are also certain states that aren't doing an all-out ban on biosolids applications, but they're monitoring it, they're quantifying it, they're requiring sampling for it as we beneficially reuse those biosolids. And then pending MPES permit standards, and this is a good little segue into the case study, two case studies that I'll address briefly. You may have water quality standards in your state, and from the drinking water MCLs, that may drive water quality standards across the nation. It may be to protect drinking water sources, it may be to protect aquatic species. You may have water quality standards that drive MPES discharges from POTWs, and therefore having to address PFAS at your POTW, sample for it in your effluent, and then therefore your influent and biosolids, and understand how that impacts your POTW. With that, I'm going to touch a little bit on this because I think it's important to learn from those who have gone before us as we embark on the world of implementing or starting a sampling program in, say, a wastewater collection system or at a POTW. And let's look to those who started it first and who have done a lot around this, and that would be Michigan Eagle, the Department of the Environment there in the state of Michigan. When they started looking at source identification for PFAS in their wastewater systems. And I'm going to run through these pretty quickly, but a couple key takeaways. One, they were very smart in where and how they tested for PFAS. But ultimately, they did a lot of sampling. They did a lot of testing, over 2,000 samples in that initial effort to identify industrial sources of PFAS in their wastewater systems and at their plants. But they were smart in the potential industrial sources or sites that they went and sampled first. And some of those are the sites we know best: landfills, military installations, airports, and the like, and firefighting training centers that we know are likely to have these impacts. So rather than taking this broad brush approach of just sampling everywhere, let's have targeted analysis and sampling and target those areas that we want to sample in the collection system and in our industries. They were also smart about how they regulated this. And so they were driven by the MPES permits at POTWs and exceeding water quality standards. And they said, okay, we understand that this is an impact at the POTW. Let's assume there's no removal efficiency at the POTW. And so therefore, kind of what comes in goes out. And so then we got to really focus on what's coming in to our treatment plants from controllable sources. this is probably an issue that can be handled through the pretreatment program and regulating controllable sources from industries. And so what did we learn from that? What did we learn from Eagle and the state of Michigan as they went through this? Well, as they regulated on those controllable sources, some of the industries discharging to these POTWs, they saw significant reductions in PFAS at the influent side of the plant. And this was a huge success. And many of you may know this, or there may be some folks from Eagle on this call. This was a couple years ago that we talked about. They're finding significant reductions to their POTWs by enforcing just on one or two industries in their collection system, forcing them to put in pre-treatment for PFAS. And we saw significant reductions at the plants. We're now able to comply with our discharge, MPS discharge limits and the water quality standards. And we've quote unquote solved our PFAS problem at our treatment plant. I'll back up. Actually, that last point down there, one little sticking point. We did see, however, occasionally higher effluent versus influent concentrations of these POTWs. And I talked about this earlier, and this speaks to precursor concentrations of PFAS and the transformation of those precursors through the treatment process at the plant. So while we did see dramatic decreases in the influent concentration by regulating and enforcing on one or two or a handful of industries and controllable sources, we still did see this anomaly. And I mentioned that because it's going to speak to a recent study that explored that further at a POTW level. And then again, the job's not done there by addressing those influent impacts. We got to continue monitoring and understand how PFAS moves through a plant, and continual monitoring at that plant to understand how we're continuing to comply with the regulations that we have. And they did a really great job of that. They did a great job of being transparent about it. And a lot of this, I got to imagine, is driven by the Flint, Michigan water crisis. But they developed this online web-based GIS where they have all of this sampling data available to the public, and you can go and look and see what POTWs are complying with the water quality standards, and you can see some of those industries that they've regulated upon and kind of understand that story in that picture. One other thing we learned through the thousands of samples that they collected from industrial sources are some of the likely industrial sources of PFAS to treatment plants. So those of you out there that are wastewater treatment plant operators and you want to know, where is my PFAS coming from? Not just Michigan, there's other studies out there, but they identified some of the major sources of PFAS to industrial sources, permitted sources to POTWs. And so if you have some of these types of industries in your collection system, I spoke at the very beginning about smart sampling, that's a great place to start. But then over the last couple of years, we continue to learn more. Michigan has and others have learned more about where PFAS is and is not coming from, and this idea of precursors. And what we found is, okay, there may be treatment plants where this is totally controllable on regulating on certain industries and their contributions to the POTW through pre-treatment programs. But what about the domestic contribution? PFAS is in all sorts of consumer products. And are we getting a lot of PFAS from homes, residential homes, commercial areas? And so this picture and this question and this conundrum became a lot more clear as we started to understand and look at precursors. And this wasn't so well studied and understood, like I said, many years, or 3 or 4 years ago, when Michigan was going through a lot of this. And this is an example from the state of California up in the San Francisco Bay Area. The Bay Area Clean Water Agencies and the San Francisco Estuary Institute did a study of POTWs, treatment plants in the Bay Area, to look at PFAS contributions in the collection system at the POTW, but not just for those target analytes, the precursors that we talked about, that larger orange circle of what about the precursor picture. And what we found, and what this graph is kind of showing here, is if you start looking at it in terms of quote unquote total PFAS, or the target plus precursor compounds, you start to see a bit more of the picture here. So you've got the influent on the left here, you've got the blue bar, which is that target analyte list of 40 target compounds, and then you've got the orange bar, which is the top assay results. It's 5 times as large of a concentration on the influent side. You see it on the effluent, the target analyte list is roughly the same concentration, but those precursors have dropped significantly on the effluent side of the plant. Where have they gone? Well, okay, let's go look at our biosolids. This was kind of a mystery for us, where we saw the same concentration on influent versus effluent, or sometimes greater on the effluent, but we also saw PFAS coming out in the biosolids. We said, are we generating PFAS at treatment plants? No, we're not. You can see it here in the orange bars. We're having transformation of the precursors. And so from a mass balance standpoint, it's all still there. It's just in different areas, and we get a better picture of that by being able to utilize this top assay analysis and look at the precursor mass balance as well in context with this. What they found through this sampling study, they sampled residential areas of the collection system, they sampled individual industries, they sampled at the influent, the effluent, and the biosolids of the treatment plants. What they found when looking at it through the lens of PFAS plus precursors is some of our largest contributions are likely coming from residential sources. Maybe not just from controllable industries, maybe from uncontrollable residential sources. And so this speaks a little bit to it. This is a concentration bar graph of some of the classifications of industries that they looked at. And again, the blue is the target analytes, and the orange are the precursor compounds. And you got the plant influent on the far left, and you've got residential as the next one. And that blue line sure is pretty small in comparison, but the orange is close to the plant influent, the top assay, the precursors. But keep in mind that residential flows to these plants are 90 to 95% of the total flow contribution. So mass equals the flow times the concentration. And so most of the PFAS is coming from residential here. It doesn't look like it in these bars. You see this large bar from laundry here on the precursor side, but laundry industries represent about 1% of the total flow coming into a POTW. While, yeah, they may have a high concentration, it's relatively low flow and low mass when compared to residential, and then on down additional industries. And so what we're starting to see is it may not be so clear of a picture. We may not be able to, at certain treatment plants, manage PFAS just by regulating a couple of industries. We may have this uncontrollable source that we have to address, and we're going to kind of talk about how to address that in the next webinar when we talk about treatment strategies. So we extended this, and I spoke longer than I meant to. We extended this so we could have more Q&A. I'll just run through the recap here. Keep in mind that through the sampling methods, there may be more than what you're seeing in the target analyte concentrations. There may be precursors, there may be other PFASs in your sample, but you're not going to know until you know. So you're not going to know if you have that problem until you start sampling. Be smart about source identification, both in water and wastewater systems, and where you sample. And then, are you going to act now? This is a question mark here. Are you going to wait until you have regulations that apply you to start sampling, or are you going to be proactive and try to address that up front by starting sampling programs? And then, as always, please reach out to the EFC network to provide additional educational outreach and technical assistance around all of these areas. So thank you. I talked a lot. I want to hear from you. Let's get into some Q&A if we can. I'll try to address some of your questions.
All right, thank you so much, Will. So we did have a couple of questions that came in through the presentation. The first one here, is the US the only country that is concerned about PFAS?
No, and that's the short answer. But in a lot of ways, there are actually other countries that are much further ahead on PFAS than us. The EU is very concerned about it, and they are pursuing regulations. Australia is another area where they are, in many ways, way ahead of the US in terms of PFAS regulations.
Great, thank you. And the next question, are the producers of PFAS chemicals protected from CERCLA by the recent settlement?
The 3M and DuPont settlement for drinking water systems is a class action lawsuit. It eliminates their liability, past, present, and future liability of PFAS impacts to drinking water systems only as a condition of that settlement. It's a $10 billion plus settlement that drinking water systems nationwide can get funding for addressing PFAS impacts if they have PFAS impacts. But it does eliminate future liability for drinking water systems only. They were very clear about that, and they are still on the hook for impacts to wastewater systems and otherwise. That settlement doesn't relieve them of those liabilities.
Great, thank you, Will. And the next question, how significant is the impact of the materials left in the environment that contain PFAS, such as used carpets, materials treated with Teflon, or fire retardants and hydrophobic substances of construction and demolition debris?
I'll be a little judicial in my answer, saying we're still trying to figure that out. We know that a lot of those products are likely contributing to PFAS contributions in waste streams and otherwise. The degree to which they are, we're still trying to figure out, really at an academic level.
Great. And make sure you get your questions in if you do have any for Will. The next question, is the same increase of PFAS observed through drinking water treatment processes? I'm imagining that something like chlorination could also transform precursors to PFAS compounds. If this is the case, is there a treatment step that can eliminate precursors before we oxidize them?
Potentially, I guess is the answer. There may be certain drinking water treatment processes that have the potential to transform precursor compounds into these terminal compounds. Typically, we don't see high precursor concentrations, luckily, in drinking water systems. It depends on whether you have a groundwater source or a surface water source, but typically we see low precursor concentrations in drinking water systems and therefore a low potential to oxidize and transform those into the terminal compounds. But there is always the potential to do so. Yes, there are treatment options available, and the degree to which those treatment options address some or all of the precursor compounds, again, is still being understood. There are treatment options like granulated activated carbon or ion exchange or reverse osmosis for drinking water systems that address many or most or all of the terminal PFAS compounds that we are most concerned about and regulating, and many or most of the precursor compounds to those terminal compounds. I mentioned the AOF analysis. That's being utilized to help get that full picture of the removal of fluorinated compounds on the influent side of drinking water treatment versus the effluent side of drinking water treatment.
Great, thank you. Next question, how does laundry produce so much PFAS precursor? Do you know if it's possibly water or stain resistant coatings or if it's a dry cleaning chemical?
I don't know that we know for sure. I don't want to get too far into the weeds. There were a number of laundry industries sampled in that study. I don't believe any of them did dry cleaning. So I wouldn't want to speculate on dry cleaning compounds. We believe it may be something to do with the application of water or oil resistant applications to the garments themselves, just because that's where a lot of PFAS chemistry is used. We don't know for sure. I would also just state that there were only a certain portion of the industrial sources to these plants that were sampled and identified. And there may be other industrial sources with similar or large bars that they just didn't capture in that sampling study. We're just starting to utilize this top assay analytical method to try to get a clearer picture on precursors in wastewater collection systems. So this is kind of one of the first studies. We may learn more as additional studies are performed.
Thank you. And the next question, PFAS MCLs are very new to water safety conversations. Because of this, it will be hard to find labs with the technology to test water samples for PFAS. And that's a question. Because of this, will it be hard to find labs with the technology?
It is relatively new, but the EPA recognizes this, and as a requirement through the rulemaking process, the EPA needed to ensure that there would be enough laboratory capacity nationally, or that there's a good enough assumption that there would be enough laboratory capacity nationally to comply with drinking water MCLs. There are a number of national chains of analytical labs that have labs throughout the US certified in these PFAS analytical methodologies, that there should be a lab relatively near to wherever you are, or definitely one in your state or within, and certainly you can ship your samples that are certified in these PFAS analytical methods. So there is capacity, there are labs out there that are available to you to comply with drinking water MCLs. Certain states may have already adopted NCLs, and so in those states there may be a higher concentration of these labs. And certainly there's going to be more and more labs getting that certification as drinking water federal MCLs are adopted, and the demand for analysis of PFAS in drinking water just explodes in the near future.
Mm-hmm. And of the 3 wastewater analytical methods presented, is it necessary to do all of them to characterize PFAS if funding is limited to pay for sampling and analysis?
No. It depends on what your goals are, and that's kind of the conversation through putting a program plan together. 1633 is the most widely used method that will give you those 40 analyte lists. Right now, no one's really talking about regulating precursors. It's really understanding how precursors may affect the target analytes that are being proposed to be regulated. A lot of that's driven by the 6 specific PFAS compounds that are being proposed for drinking water MCLs, and how that affects water quality standards and therefore MPDS discharge limits and effluent limitation guidelines. So really, right now in 2024 and in the near future, we're only talking about regulating a handful of specific PFAS target compounds, all of which are included in the analyte list of 1633. So for the purposes of current or future compliance, 1633 is enough. For those that want to understand the bigger picture, there are additional analytical tools available to them.
Perfect. Next question, do you know what the costs are associated with PFAS sampling? Maybe how much per sample?
It's not cheap, I'll say that. And I would encourage you to reach out to a certified lab to get a quote for what that sampling would cost. I will throw out very round numbers and say on the drinking water side, 533, 537.1 will run you roughly $200 a sample. And then on the wastewater side, 1633 may run you roughly $400 a sample. You could also do a modified 537.1 for wastewater, which may be marginally cheaper. The top assay will run you roughly, again, very round numbers, $800 a sample, and maybe similarly for the AOF analysis. I would recommend that you reach out to the lab certified in these analyses, but they are not cheap. We do expect, as there's more demand in the market and additional competition enters the market with new labs coming online certified, that would drive the price of these samples down in the near and long term.
And that'll take us to our next question. Is EPA 1633 no longer in draft form?
It was finalized as of, I think, January 31st was the date. It has not been promulgated through rulemaking under the Clean Water Act, so it's not required to be used for compliance purposes, but the method itself, going through the multi-lab verification and the complicated process, which I won't pretend to know everything about, that 1633 method has been finalized.
All right. Are you aware of any effects by the drinking water and wastewater treatment organizations to reduce the use of non-essential uses of PFAS and to force users and producers of PFAS to recycle and or eliminate PFAS into sewage water?
I am aware of efforts by the federal government to do just that. I think it was just last month that the White House announced restrictions on legacy PFAS compounds in consumer goods. There are reporting requirements of PFAS use now in the production space and manufacturing space. There are requirements to submit essential use of PFAS chemistry in products. That all is very quickly ramping up to try to regulate and restrict the use of PFAS in manufacturing and production side of things. I'll caution that by saying it may be harder to regulate outside production, overseas production, and the importation of consumer goods into the US. But it all centers around the ultimate solution, likely, is product substitution and the elimination of PFAS in consumer goods and in products. But that's a long road and very complicated road. Efforts are being made, though.
All right, and the next question. So is it likely that wastewater treatment plants will eventually have to add PFAS treatment prior to discharge?
Maybe some, likely some. Again, there was that graphic of industry versus domestic contributions. Can we control the main contributions to our plant and not have to put in treatment at the plant level, because we can regulate certain industries that are contributing that PFAS? Or is it largely an uncontrollable issue, domestic and commercial sources, that we don't have a permitting framework? We can't ask residents to put in PFAS treatment at their house on their sewer line. So is that an uncontrollable source? And if so, do we need to put in treatment at the POTW level? We're going to explore that in the next webinar on the treatment side of things, and how complicated that could be for wastewater systems, given the treatment devices and technologies available to us. So likely you'll start seeing some amount of treatment at the POTW level to address PFAS. It may be combined with additional drivers like IPR and DPR in water scarce areas, but that is a big unknown. It's a big question of how many plants across the nation may have to implement PFAS treatment at the plant level, and what the ultimate cost may or could be to comply with what those regulations might look like. A lot of question marks.
All right, and the next question: to do our part at home, and since there is no regulation on labeling, what should we be looking for on new products? I've seen labeling on boxes that claim that it's PFAS free, but I don't know how true these statements are.
Yeah, it's a good question. It's a big challenge. My guess is you're going to start seeing organizations that, you may have like fair trade certification or Rainforest Alliance certification for certain products, these stamps on these products. You may start seeing something similar pop up for PFAS, and there's certain ways that they have to demonstrate they're PFAS free. You're starting to see it though. Go walk down the kitchen aisle at Target, and I did this a couple weeks ago, and on all the frying pans, you're starting to see on the packaging PFOA, PFOS free. So they limit it to those two compounds. They don't say PFAS free. So there's creative ways about defining what PFAS may or may not be in products. I would also point you to the Environmental Working Group, EWG, Environmental Working Group, as a resource. They're doing a lot in this space, sampling consumer goods and putting that up on their website. What cosmetics have PFAS in them? What have we sampled? What do we suspect has PFAS? That type of thing, if you're looking to do your part at home.
Thank you, Will. And I just I dropped the website for the Environmental Working Group in the chat in case anyone is interested. And it looks like we have time for one more question, so we'll just get through this last one. Have you heard of the recent study on boiling water enabling the capture of PFAS in calcium deposits? Is this promising, or do you think it would take up too much energy?
What it kind of gets at, boiling water, is the phenomena of PFAS being attracted by air bubbles. And you can look up foam fractionation. It's kind of a mouthful, but foam fractionation is we call it a separation technology, trying to separate PFAS from the water column or the water matrix by introducing air bubbles, attracting the PFAS, and generating a PFAS foam at the surface that we then collect. So you may be seeing a similar phenomena in boiling water, where the air bubbles attract that PFAS and pull it out of the water column. And there are also volatile PFAS compounds that may be volatilizing through that process and then finding their way into the air side of things. But a lot unknown around that. I don't know of the specific study that you're referencing. I'd be very interested to read it and try to understand it. But again, another area that is in its infancy of understanding how certain processes affect PFAS in our environment.
Perfect. Thank you so much, Will. Thank you for your time and thank you for sharing your expertise with us today. Following this webinar, each of you will receive a follow-up email with the slides from today, as well as a link to the recording to this webinar. We also ask that you please complete the webinar evaluation. That allows us to know your thoughts on today's session. It also helps us plan future events and webinars on topics that are important to you. For example, the next PFAS webinar that we'll be holding, or not the next one, the one after the next. So thank you so much for attending, and we hope to see you all at future EFCN webinars and events. Thank you, Will.
Thank you so much. Have a great day.
Bye.